They may not ask, but just in case they do.
Sure.
Can you have Josh mute phone? Just remember to unmute when he wants to throw a question my way. Okay, thanks. I was getting a lot of stuff coming. I was hearing myself talking. I still am.
Well, we got a minute.
We're live.
Just check and see if my watch is right on.
Welcome to another episode of Bourbon with the Editor. Here again with our friends from Vargus, USA. We've got Joe Vargus, the manager for all the application engineers, and Phil Gish, application engineer from the southern Indiana area.
Yes, sir.
And, before we get started, I got to do my little bit about the bourbon we're going to be sipping today. And I decided that I wanted to try to pick the bourbon a little bit different way. So I turned to ChatGPT. And
ChatGPT is what? I'm an old guy. You got to bring me up to this.
It's just a little online AI tool, that people use these days. And I call ChatGPT, I've got a personal relation. I call him Chet. So
it's a road we don't
Chet,
need to go down.
I don't like to talk about my personal life too much, but Chet told me, said, yeah, sure, I can do that. What are you covering? So
AI is going to tell us the
bourbon.
The bourbon.
So I told him. I said I fed Chet the the discussion of what the description of what we're going to talk about today, thread milling and the whole 9 yards. Some of the different.
Oh, this ought to be interesting.
Sections of the topics that we're going to cover, and he did. I'm calling him he because Chet, whatever. He suggested.
Not sure if that's illegal nowadays. You're picking out that preference.
No, he doesn't care.
Okay.
Chet suggested a really good bourbon, Elijah Craig, barrel proof, and I'm just going to hold it there. You can see it right there on the screen, I think, but that's it. And, it's a good bourbon for today. For one reason, if you don't know what barrel proof means, it just means that bourbon is not watered down. It's straight from the barrel, so you're getting the full strength of that.
So that barrel's been sitting there for years and years. And they're pulling this right out of that barrel without diluting it at all.
Yeah. By the way, Elijah Craig it's distilled and bottled right there in Bardstown, Kentucky. So
nice.
It's
2 hours away from my house.
Oh wow! So and you see,
We covered this last time.
You might have bumped into Elijah Craig.
You brought the Kentuckian up here that's not a bourbon drinker.
I mean, that's okay. He's got some water, but Joe Vargus and I by the way, it's McGee. You don't have to go by his last name. I think Joe Vargus is a better.
Hey,
it's the beginning of a legend. But Elijah Craig, by the way, getting back to this, because my son is probably going crazy. The tangent I've gone on
I know
already.
Tim's going. Hey, we're off schedule already.
He's known as a legend. Actually, he was a Baptist preacher. There's no truth, or not truth, but no actual evidence that he's the father of bourbon, at least coming up with the charred barrels of
right.
that they put the whiskey in. But when Chet spit out what it thought would be a good pairing, it came up with this, and it's I'm just going to read what it said. It says, why? Well, this bourbon is bold, unfiltered, and strong. Just like the kind of high-performance threading we're going to be talking about today.
There you go.
So
That AI is pretty smart stuff.
it's fun. That it can distill all this stuff into. But I wanted to mention the barrel proof because it is a strong bourbon. It's it's 118 proof, just a little bit more than that, but it's got a nice toasted oak, rich caramel kind of a flavor.
Yeah.
To me, it's just a good bourbon, but it's one of those things that they made it so that the taste is precise, and it's built or made for those who appreciate craftsmanship, which is why this is a good bourbon for today, because Vargus is all about the quality and craftsmanship. So, with that, we're going to move right into we've got some little quips from Chet later, maybe, if we have time. But for now, we're just going to say cheers, and we're going to get this thing rolling, because we have quite a bit to cover. Trying to get into some tips for some thread milling here, and where some of these tools come into play. So we've got a few tools to cover.
So we're going to cover some Vargus solid carbide thread mills, different types, the reason for those types, why you would want to use one thread mill over the other, some of the advantages of each one, and some application tips and hints how to make these work. So it's going to be a little technical, but we're just going to be able to answer a lot of questions on why you pick out a certain thread mill over another one. So Phil's going to go over some. He's been some of them that he really likes to run. He's ran a lot, and we'll go from there. Phil, it's up to you.
I guess we could start off. One of my favorite ones that we offer is the TMDR. It's the thread mill that I guess it came out just shortly before I came aboard with Vargus about 3 years ago.
Phil, can I just...
Sure.
I think it'd be good if we let everyone know what it is you do as the application engineer. Just kind of give me 25, 50 words of...
Yeah, as an
your role.
application engineer, I guess my main focus, I go to our end users, our customers, their shops, and probably the majority of the job, we're there to solve a problem. And obviously the goal would be to solve that threading problem or whatever machining issue they have would be with one of our products. That would be the roundabout way I would describe what we do on a day-to-day basis.
And a lot of times it's help the whole process. Not
Yeah.
necessarily just put our product in there. We bring one of our guys with highly technical history, knowledge. They'll come in here and help our customers improve that whole process. Sometimes we do it, and it's don't even take our tool. But if you bring us in, we're going to help you solve that threading problem. It might be from drilling, might be from location, might be a lot of problems that you're dealing with, but that we're here to help you solve your problem. That's what we do daily, everywhere across the country.
So it's kind of like a consulting role. At
Yeah.
some point, it's like that. And then, so let's say this is a customer. How long would you be there for a visit, let's say?
Oh, that's a good question. Sometimes you can. It depends on the problem that they're facing. I've walked into shops and been there 20 minutes, and resolved the issue that they were having. And as Joe said, it may not even be with our product. It just may be an overall process issue that they're having. And then there's times that I've had to go out of town and be gone for a couple of days to battle through a complete a part setup and helping them get everything kind of efficiently running how they would need it to be running to maximize obviously their throughput and the profit that they're trying to make. So yeah, it's like Joe said, it's not just walking in with one of our tools and saying here you go and let me know how it turned out and I'll see you later. It's we're usually there for the long haul. I mean, when we walk in the door, I usually don't leave until that whole process is running, not just my tool. So
So usually there's there's three reasons they bring us in: the cost of running that part, the process of getting a good part, or just how to run a part. That's usually the three reasons. There's one of those who usually, and then they need help. You know, if it's a simple part and they can run it, they don't call us. They just do it and move on. But when they come into tough jobs, they'll call one of us, and then we'll come in and help them.
So, why would someone decide to use thread milling over tapping?
So usually at the end of the day, tapping used to be, you know, it was the way to put a thread in a hole, and I mean, it still has its places. Thread milling has a lot of what I would consider more positive aspects of the machining process, as far as you get better chip evacuation, because a tap is the diameter of the thread you're putting in. So you're really limited on the space that's down in there for coolant and chip evacuation and things like that. A tap is limited to the size of that tap. A half 13 tap is going to do a half 13 hole. A thread mill you can bring in, you're going to get the better chip evacuation. If it's a 13 pitch thread mill, then you can do that half 13. You can also do any other 13 pitch hole that you may run across with that same tool. And the biggest for me as an ex-machinist and working in shops is when you break a tap, you know, you're taking it's a big risk. You're scrapping that part if you can't effectively dig that tap out of there and recover that hole. Whereas a thread mill, since it's so much smaller than the minor diameter of the hole that you're trying to process the threads in, if it breaks off in there, you know, the majority of the time you take your air hose and blow the end of that thread mill out, throw you another thread mill in, and you're set up and ready to go and continue on with what you're doing there.
Yeah, I'm sorry to interrupt, but I wanted to kind of get that, like the setup for, you know, why your role for Vargus. So now you're there, and I think we should go back into the what was the tool that you were starting to talk about? The TMDR?
The TMDR, yeah.
Yeah. So now let's say you're there and somebody wants to learn about that.
Sure. So when I walk into any of my end users, or whether it's a new customer or not, I first like to try to know what I'm walking into as far as the application they're trying to do, because I want to bring in the tool that is going to generate them the best outcome. I don't just want to walk in with a tool that, you know, is going to do the job. I want what's going to be the most efficient tool for them. So I like to kind of have an idea of what we're doing, the machine we're going to be doing it in, the material we're going to be machining. There's quite a few variables that come along with it. So all of us at Vargus we like to do this so that we can walk in there with maybe 2 or 3 different options, because I want to walk in with a handful of options to get this done, get it done the right way, and maximize their time, because I want them to call me back. If I just walk in and throw a couple tools on the table and say, here you go, this should do the job, and then it doesn't achieve maybe the cycle time or the tool life that they're after, then they're not going to call Philip back in there. They're going to call the next company. So getting all that information up front, the complete application that we're going to do, will let me know what tools I need to bring in there. If it comes down to where I'm going to bring this TMDR in there, it's a niche tool. It's not there to go super fast. The majority of the time that you're going to use it is if it's a harder material. You'll get a truer position tolerance on a hole with the TMDR, because you're doing the entire hole with one tool. You're not spot drilling, chamfering it and chasing it with a tap that could possibly walk out of position a little bit. So if your hole tolerance is, your position tolerance is really tight, I'm walking in there with the TMDR. It's a good tool. It's really beneficial on multi-axis lathes where you're super limited to tool holder space. because this is basically a 4 to 5 tool in one. You're getting a spot drill, a chamfer tool, a drill, and a tap all in one tool is what you're gaining. So it's
Especially if, let's say you're doing a part that you got to heat treat. So you need to run them threads 2 to 3 thousandths, maybe more, oversized, just so when you heat treat it, they'll shrink down. Then if you have this tool in there, you would have to have a special tap for that. This tool, if it's a half 13, you could run it oversized for the heat treated part and use it for the standard too. It's all adjustable in your program. One thing you can't do with a tap, every size has to have their own tap.
Does it work, the TMDR, does it work on an incline surface?
yeah, it's if you were having to maybe put a hole on a taper on a part or like an angle or a step, since it's a center cutting like an end mill would be, you can do that pretty easily with the TMDR. It's a good versatile tool. It has its places for sure, but it'll get you through a lot of tough spots when you need to.
Okay, yeah. That's, did we show a video of?
Yeah, he had it running when we were
okay.
discussing it. So
I was looking at
I
you.
think,
guys.
I think we're good on the video with that one.
It's a tool that really solves a lot of problems if that's the problems you have. If it's like Phil said, if you just want to go fast, it's not a tool just to go fast. We got other tools that go a lot faster, but this solves a problem and a lot of need out there for something like this.
What's a typical programming cycle for the DR?
It's going to program basically the same as a regular thread mill would, because some of our thread mills, the majority of the time when you're thread milling a hole, you can run down to the bottom of the hole. And thread mill, you want to climb mill, so you're going from bottom to top. But on the TMDR and our Millipro line, since they're center cutting like an end mill, they're designed to work from the top down. Obviously, the TMDR has to be that way because you're not drilling a hole, so you don't have a hole to, run down through to thread your way back up to the top. So, as far as the program goes, it's going to be very similar to just regular thread mill programming, which all thread mill programming at the end of the day is a little bit different.
And it's all
Depends on-
supported by our Genius.
Yes.
We want to bring that up as much as possible.
Yep.
It's the greatest tool for threading out there. So all the tools we talk about supported by the Genius. You can go in there, write a typical program for you, give you a chamfer size, everything like that, and then print out a summary. What do you think?
Does it use flood coolant or through coolant?
Oh.
We have the TMDR. We offer it in both.
Oh.
You can flood it, and we do have through the tool coolant on it as well.
Nice.
You get down
Which-
to a real small size, I think under about 3 millimeters, it's all flood coolant. We just can't get down to very small. I believe this goes all the way down to 440, don't
I
it?
think you're right. You get down to the smaller sizes. The reason, as Joe was saying, is the diameter of the hole that you put in through coolant tooling. I mean, once you get down so small, you can't.
You're
can't
going to
have the hole
weaken
there.
everything.
Yeah, you make the tool very.
An inch, I think it goes from 440 up to a 1 inch diameter. So
And we can verify that and nail that down.
Oh,
for
yeah.
the recorded version.
Yeah.
All right. So
I
What
think
else?
the next one's going to be the.
Millipro HD is what we got next on the list, I believe.
Okay, good enough. Let's talk about it.
So-
and I just want to note that it's thread milling. It's not one tool, right? I mean, you have different tools for different reasons. So
Sure.
give us the reasons for the Millipro HD.
Yeah, the Millipro HD is specifically designed for hard materials. It's one of those tools like the TMDR. It's a reverse spindle orientating tool that you start at the top and work your way down. It has a roughing teeth on it, and then it has the finishing as well. That's why you start at the top and work your way down. But it is designed for hard material. 62, 64 Rockwell, no problem. it's a good tool for your high resistance steels, your Inconels.
So you can get the roughing part and get all the way down to the finishing part with one tool? Is
Yes.
that- okay.
Yep. And it's good for the tight tolerance hole positions. People will whether it's in the mold industry or whatever you're doing, and something needs to be hardened, and you need that hole position to be super close on as far as the tolerance goes.
Mm-hmm.
And you can pre-drill the hole before it heat treat, and when you bring it back and you run the Millipro HD down through there, it's going to be on position.
You know, we're kind of talking more about the technical aspects of each of these thread mills now, since we've introduced them all once before. And I was just thinking, our Millipro and the TMDR all run left-handed. And most programmers, controllers, most software will automatically default to an M3, a right-hand tool. So there's a lot of people saying, well, I broke it right off. Well, they're running the wrong way. The machine itself is defaulting back to what it thinks you're doing. So everybody needs to be, I think I'm right here.
Yeah,
everybody
you're
really
correct.
needs to be very careful when they're programming this, that they know what they're doing. That's why running it through the Genius, you get the information what you need.
We like to put this pretty big red sticker on the box. I don't know if you can see it real good here. It lets you know that this is a left-hand tool. But like I said, as a guy that spent 30 years working in shops,
A lot of people are colorblind.
I don't always look at the box. Sometimes this cap comes off and
Well, why
chuck
does
it right over
why
my
does
shoulder.
it have
so.
to go left-handed?
It's because of the design in the tool and the application you're using. Since it's center cutting like an end mill, it has to go reverse orientation to work its way down. You're basically
back
thread
fish
milling. Yeah, you're kind of thread milling backwards. A majority of your standard thread mills will do an M3 orientation as far as the spindle coating on a program, and they work from the bottom up. Well, this tool works from the top down, so you're running it as a M4 direction to get the right hand thread in there. That's how that works.
And these tools, like you talked about, have a roughing row of cutting teeth and a finishing row. So instead of being one half thread away from the bottom, if it's a blind hole, this one would be 1.5 threads off the bottom. So it's a little bit different too than a normal thread mill where you're only about a half of a pitch off the bottom of the hole.
Okay. So it sounds like a pretty handy tool.
Well, I think we got some data to go over, don't we?
Yeah, I believe we have the Millipro. I don't know if we got the test report for the Millipro. I know we had one for the TMDR. Yeah, we have no, that's for the HCM. We didn't do a
There's a
That's okay.
Millipro HD
TMDR
test.
case
Yeah, we had a
study,
TMDR case study test report that we did. So it's not; these two tools are not too far off from each other,
Yes.
in my opinion. So,
So you can hit the highlights of that.
yeah, we can just kind of.
The TMDR case study is up showing.
Yeah.
Everyone can see that right
So
now.
as you can see in this case study, this was a heat-resistant material. I won't go through all the details on this. We've done this before. So as Joe was saying, we're just trying to lean into getting these a little more technical, giving you some information on what the tools have done in the past.
Yeah.
This one here, like I said, was in a titanium material. It's in the ballpark of 41 Rockwell, and you have your run parameters on here that you can look over, and it'll break it down and give you the process that they did, the actual application that they did. It'll tell you the surface footage that they ran, and it'll give you I believe there should be a cycle time on here. Yeah, there's a cycle time that it gave on how long it took to process this particular hole right here. This was a metric hole, M3 by 0.5. So, like I said, you can see on here everything they did. It gives you the surface footage, the speed they ran, and all that good stuff. So, the one start gave you the pitch and all that good stuff. Like I said, I'm not going to go into super detail on these test reports. We've done that. So,
Right.
Cool. We going to talk about MultiFlute?
I think that's the next one up.
Yeah, MultiFlute should be the next one that we have on the list. The MultiFlute is kind of designed to, you need a little bit extra depth. So Vargus come up with the MultiFlute design. MultiFlute, it kind of basically, it's in the name, it's multi-flute, a standard thread mill where it may be 3 to 4 flutes. This one will be quite a few more than that, 6, 7, 8, 9 flutes. And what that does is when you're trying to thread mill a deeper hole, the longer the tool is, the more tool pressure that you'll generate. And when you generate tool pressure, you'll get deflection, so you'll have a distorted hole. The MultiFlute eliminates those problems. It's with the more rows of teeth, your chip thinning drastically, I guess you would say, increases. You have a much smaller chip. You have a lot less tool pressure that you're
Well, how does that
producing,
helix
so
angle affect the tool pressure?
it relieves it quite a bit.
Okay.
And that's what you're obviously after. When you thread milling, any type of milling, the more tool pressure that you can reduce, the better process, the better tool life you're going to gain, the faster you can run it. So it's a good all around design.
It also makes the core of the thread mill thicker.
Yep.
So when you run a standard program for a MultiFlute is like 5 passes instead of 2 passes. So they're running light depths of cut really fast, and with a stronger tool, push it a little bit harder. So you get more material out at the same time in more passes. So that gives you less tool pressure, less deflection.
Okay, I got to jump in here and just make sure we're enjoying our bourbon just for a quick sec, because, based on what you're just saying, Chet also told me I could throw in a few little analogies
All right.
here or there. If you're going 6 or 7 times deep with a thread mill, it's like drinking barrel-proof bourbon neat. You gotta watch. You gotta know what you're doing, or it'll knock you on your back. Just so everyone can see, I've got it with ice.
There you go.
So just thought I'd throw that in there.
That's good. Yeah.
Okay. All
I'm
right.
starting to understand that. Chat, or whatever you call him now. So, the MultiFlute has its place, and it's really, especially for production, it's really good.
Let's see. What was that? How fast can you? Yeah.
It-
How fast can you run this? As we're talking about, drinking too strong a bourbon, as you're witnessing right here. So, how fast can you run this?
Well, it depends on the material, but
And I think we have some information that people can watch. But yeah.
So it depends on the material, but with our grades and this type of machine, this type of tool, we can machine it a lot faster than a standard. Even our own standard, we would run the surface feet probably 30-40% faster. So we're gaining there. Then also, when you lighten up the cuts, take them faster, you're feeding faster per tooth. It gives you much better performance overall. So you're looking for quality, quickness, reduce your cycle time. This is a tool that we can do that with. So
I think we have an example of our run parameters up on the screen right now.
Yeah.
This right here is something that Vargus offers when you're thumbing around through our catalog looking for something. Every tool that you come across when you're going through all the different tooling, whether it's our carbide, our solid, or our inserted thread mills, or any tool that Vargus offers, actually. Once you get to the end of that section of the tooling, the run parameters chart for what you were just looking at will be in the catalog. They do that through every section of every tool that we offer. So it'll give you the breakdown of all your different materials, and then you'll have your surface footage breakdowns and your chip loads per diameter of tool or per diameter of hole what you're running. So it's all there. It's all very useful. It's pretty user friendly in my opinion. So
Yeah. other tools for long threads?
Um,
HCM.
would you really consider the HCN? They're not for long tools.
Well,
the longer, deeper holes.
It's a lot of times you need a tool with a shank relieved, so you
Yeah.
can get down into a hole for a sharp corner or something like that. So we came up with this HCN style. A lot of times we had people say, "Well, I buy your tool, then I have to take it over and grind the shank down to reach in the hole, get past a clearance for a clamp or something like this." So after a while, we decided, well, we'll just make a standard line, and that's what the HCN is.
It's
It's
the
a
video that we're watching right now.
Yeah, that's the HCN that we're watching right there. And as Joe was saying, it's. I mean, yeah, it could be. You could definitely use it for deeper hole application. As you can see, that it's got a shorter row of cutting teeth on it, or the length of the cutting teeth are a little bit shorter than what a standard thread mill would be, and then it's cleared from there up, so you can multi-pass a hole to accommodate a little bit deeper depth of a hole.
Especially when you got only flood coolant. There's still a lot of machines out there, probably 40-50% has only flood coolant. So if your shank is the same size as the hole, there's no coolant going down in beside it to flush it out. This tool allows that the coolant can run down through there, help flush out the small chips. So that's a big deal too. You never want to recut chips. And
If you can help it.
That's a fast way to break tools right there.
that's right.
And I think we have a test report from this one.
Yeah,
this
the
one?
HCN test report is should be popping up here before too long. Again, this one here, it was just when I picked out the test reports, I tried to pick stuff that was a little more difficult generally than just cutting like aluminum or regular 4140 or something, hot roll or cold roll or something like that. So this test report that you see here was done on stainless steel 304. Anybody that knows much about that knows that it's not fun to cut. It's an abrasive material. It's it's gummy. It doesn't like to break chips. But again, I'm not going to go into grave detail on these test reports. This one was for the HCN. It talks to you about the material that it was. It's only around 34 Rockwell, which is not hard, but like I said before, it's an abrasive material. So it's a little difficult. But this one here, you'll see that they were running a surface footage of around 300, breaks down the spindle speed that they were running, climb milling obviously, and then the chip load that they used on this one and a cycle time as well.
Is this, when you say it's the test report, just so everyone understands, was this just a test you guys were doing, or this is for a customer?
No, usually when we get, if it's on our what's called the VKP for us Vargus guys, what I will do if I'm walking into a shop, one of the first things I do once I figure out the application that they're going to use, I'll jump on our knowledge portal and I'll go straight to the VKP and I'll start digging for some similar processes that were done to what I'm walking into. The test reports that we turn in, those are real-time events that happen to us in a shop. You know, when we walk into a company that's never thread milled, or maybe they've never used our thread mills, and you know, we'll bring tools in and let you try them. We want you to try it and make sure it works before you buy it. It goes back to if I just throw a tool on the table and say, here you go, then if it doesn't work out for you, you can't get it to work, then you're not going to call Philip anymore, and I don't need that. So I'll get on the VKP. I'll find an application like this one if I was going to be cutting some stainless somewhere, and I'll see what they did. So this gives me a really good jump on where I need to start when I walk into this end user with a tool. So that you know, it takes a lot of the guesswork out of it, I guess. You can walk in with run parameters that are super close to probably where you're going to wind up at the end of the day. So,
And any of the tools have radial flood coolant?
Yeah, we have the HCR line that it has coolant radially. It's designed for through holes mostly because for a through hole, because a blind hole, the coolant will fill up in the hole and that helps you out. But if you have a through hole and you're using a tool with through the tool coolant, then it's kind of it's not doing you any good really. So the HCR line is a radial coolant hole or tool, and so it's blasting out the sides of the tool, so you're getting the best coolant flow that you can possibly get out of that tool.
You know, he said something I wanted to make a comment on. There's a lot of people who sell tools out there come in and say, hey, I got a tool. I'll give you a tool. If you don't bring any help to the engineer, you can buy him donuts every week and won't do no good. You got to come in there with a tool that's going to solve his problems.
Wait. What kind of donuts?
Well, I'm not sure, but I did
Sorry.
have a guy tell me one time, I bought him donuts 2 weeks in a row and he still don't call me back. I said, sometimes it just doesn't work that way in our business. You got to come with something that's going to help him get this job done, because he's got to get them parts out the door. That's why they call Vargus. Our guys come in prepared and ready to do the job and solve your problems. As much information we get up front, it's better off for us to come in and have the right tool at the right time. So it's very important to get the information to us.
Did we have the video of the is it HCR?
Yeah, they were showing the video of the HCR running just a second ago. There it is again. So you can see the hole right there real quick before the spindle takes off.
Yep.
That's a coolant hole right there, and there you go. There's the full on live view of how it works.
Yeah, this is real time, right?
Yep.
You have a lot of people out there say, well, it doesn't really matter. The more lubricity, that's a good one. Anyhow,
Lubricity.
you can get in there, in the hole, that keeps that working and make you much better threads. So if it gets dry, it gets warming up in there, you get in trouble. So a lot of people don't think coolant's important, that important in tapping or threading, but it is.
Lubricity.
No, I don't need.
What's our next one? On black drilling or? Oh, the MACH thread mills. Okay.
Yep. Yeah, the MACH is up next. I know we've talked about that one before. I cannot express enough on how insanely beneficial this tool is all the way around. I'm not going to lie. I doubted it when they first told me about it. Some of the stuff that they said it would do, turns out they were right. It's an extremely impressive tool. This is the one that when you walk into a shop, if applicable, because a lot of people, when you start trying to talk to them about thread milling, one of the first things they'll always say is that I can tap it faster.
Okay.
And that may be the case on a lot of thread mills, but not this one. You're not gonna outrun this one with a tap.
So,
I've beat taps. I've beat people tapping in aluminum. I've beat it with this thread mill as far as the speed.
So is there? Can we talk about a customer specifically that? That it's kind of like Paul Bunyan, cutting down trees versus the machines. What does it take to show or demonstrate the ability of the MACH to
You
convince
gotta,
someone that you can't tap this? You could, but there's a better way. I mean,
so
what does it take?
that's always the hard one, because you're not going to walk into too many shops that they don't have a million taps laying around. And a lot of companies, we're all here to save money, right? So, it's a difficult task to get people to jump on board with thread milling in general, not just with the MACH, but just like I said, in general, because everybody is so used to tapping. But once you get through to them, that's why Vargus, we offer so much our test tool.
And there's nothing wrong.
processes.
Just so we're clear, there's nothing wrong with tapping. If that's
No,
that's the right tool for your job, fine. However, there comes a time when the hammer,
Well, if you
you're
have
trying
all
to
the
screw a screw and you don't use your hammer.
right.
Right.
Well, also if you have all the questions answered. Are you running at the cost that you need to run it at? Are you getting a good quality hole? Are you getting good parts all the time out the door? You're not scrapping parts because you're breaking taps. If all of those things are done correctly, you don't need a thread mill. You're making money and you're doing it at per what you quoted. That's great. But when you're missing one of those, you're not cost, you're not at cycle time, you're not making good holes, you're not making good parts, and you're scrapping a bunch, you need help. And then that's where we'll show you what we have to offer to help you with one of those situations.
And that's one of the things that seems to me like would be helpful watching this is that, you know, there's more than one tool to put thread, to create thread.
Correct.
And thread milling is one way to go about it when perhaps tapping isn't the most productive and efficient way to get it done. Is that fair?
Yeah.
That's very fair. And like I said at the beginning too, you're limited with the tap. We sell taps. I mean, I'm not here to knock tapping because
Right.
we sell them.
I mean, that's what I'm trying to say. We're
Yeah.
not saying
we're not
thread mill over tap in all cases here.
No.
It's not always going to be the best, but as Joe was saying, if you actually can get people to sit down and look at their overall process of cost, cycle time, tool life, scrap generated from broken tools, probably 95% of the time they're going to go, you know what, we probably should thread mill this.
And how do they decide which thread mill is the right?
That's why we're there. We're gonna bring in, quite a few different options. So we're gonna try them all. We have the Vargus Genius.
Because you're not even sure when you walk in. You're not even sure what might be the right one, but you've got ideas.
Yeah,
ahead of time.
not always, but I'm pretty good. So
That's right.
You're right. Not always are you going to know. That's why I like to walk in with options because there's so many things in machining in general that play a part on everything that we speak of as far as cycle time, tool life. I mean, you have to know the setup. You have to know the tool holders that they have available to use. All those things play a huge part in any machining process. I can sit here and tell you all day long what this tool will do, and then when I walk in and you're holding a part, with a vice jaw that you modified, and you're only holding 3/4 of a 6-inch bar, and you've got a teeny tiny holder, and you want the thread mill to hang out of it 8 inches. Well, everything that I told you on the phone, it's not going to work. So that's why I like to walk in with options.
Mm-hmm. And I can remember a long time ago. I can do that. Back when they first started machines, there were only 2 axes. You couldn't thread mill. So it's evolutions. The machines are getting smarter and better. 3 and 4 axes, 5 axes. You can do a lot of different things. So putting a threaded hole in a part is changing too. At one time, like I said, back when I was 60 pounds lighter and a lot longer hair, we did tapping a different way, putting threads in a different way. And then things change, gets better, quicker, faster, and more cost effective.
Okay, Joe Vargus. Well, that's what
you got next there, Phil?
Some helpful tips for thread milling?
The overall helpful tips, I would say we're probably going to touch a lot more on in the future with these. We've covered why we feel like thread milling is probably a little bit better of an idea. Common issues that you'll see with your chatter and your chip evacuation and thread distortion. I believe we've talked about quite a few of those tonight. The possible causes, we went over that too, the tool holders, the setup and all that. So I think from here on, we're going to start trying to get a little more technical. We're going to start focusing on 1 or 2 of the products at a time instead of covering like we did tonight. We wanted everybody to be aware of our whole carbide thread mill line. So,
right.
But as far as the technical aspect of it, we're going to start down that avenue so we can really get to the meat of how to thread mill, when you need to do it, how to do it from
And different
you know,
challenges
yeah,
along
the
the way.
different challenges, the different materials.
I mean, there's a lot of discussion that people don't understand that thread mills are meant to run fast. You know, you tap at a slow RPM, it can tap all day, get great tool life, but thread milling is meant to go fast. Get it done, get it out of there, and be over with. So that's something we want to show. Like I said, like Phil's saying, we're going to get more technical, tell you why, how, when you should be thread milling.
So, for instance, how does thread mill handle, versus tapping, I guess, versus burrs, versus thread mill versus burrs?
A thread mill, again, it's going to depend on the application and what you're trying to do. If you get into a full profile thread mill, which that does basically means you're cutting the entire profile of the thread, your burrs are almost all going to be almost all a bit obsolete. You're not going to have a burr on your thread. You could still have a little bit of an entry exit burr issue, but as far as the entire profile of the thread all the way down through the hole, you shouldn't see that issue at all. If you are, you probably got some tool life and out of it, and you're starting to show tool wear, but you're not going to see the burr issue is not going to be there. Definitely not nowhere near as profound with a thread mill as a tap.
A thread mill removes the material completely, and taps form it. There's forming taps. All taps form some, so it fills in. So you're always pushing the metal around with a tap, a little bit or a lot. So when you go in there with a thread mill, you're removing all that material. It's a good clean cut.
Okay, so I mean that's just something for everyone to pick up on if
Sure.
they were wondering some of the benefits of doing one over the other.
Well, thread milling's not tapping, and tapping's not thread milling. There's two different things.
Right.
They're all putting threads in a hole or outside of a part or something like that, but they're not the same operations. They're completely different. And once you get over the stigma of, wow, that's a thread mill, it's hard, it's difficult to program, it's too fast, it's scary, it's like the boogeyman or something, that it's not. But you just have to learn how to apply it, and that's what we're going to try to start showing people how and
Sure.
when to apply these tools.
What about thread milling thin-walled parts?
What's that?
Thread milling with thin-walled parts.
Yeah, it's a good idea because, as Joe was just saying, you're cutting. You're not, you're doing more cutting with a tool that's, you got the tools are radial for the most part. Your chip thinning is almost non-existent, so you're not putting a lot of pressure on the tool or the part. So it's gonna help you in that scenario.
Okay.
Quite a bit. So
Good.
So also I think a feature we're going to go on with our next segment is we want our viewers to say, hey, I see this tool you have. What about this tool? What about an MITM? What about a TMDR or a TMSD? So any questions out there, anybody's got some applications, you can get with us, send it in. We'll actually cover some applications that we receive in before our next episode. So that's something we want to start and help people in the real world. I can sit up here and talk about what I've done in my past few years all day. That I just like hearing myself talk.
I've been accused of that myself. So yeah, we are looking for the Bourbon with the Editor, especially here with you folks, Vargus. We are evolving, and I mean we've spent a lot of time talking about a lot of the different tools you have, and I think it's evolving in now to a point where we want to spend more time on case studies and actual challenges and how we've helped.
And we also at
you've-
Vargus we have other stuff too. We have gear milling, spline milling, we have small hole boring, we have cutoff tools. We have a lot of different stuff besides just threading, If you know Vargus, you think it's a threading company only. We're much more than that. So we have a drill line coming out, an end mill line coming out. So we have a lot of stuff to talk about, but it's all about solving problems for the customer. We're here to help you with problems. So you got a problem, they can get it questioned into cutting tool engineering at. I don't know your website.
Oh, just go to ctmag.com and frankly, we'll put an address and a link at the bottom of the
Sure.
of this video for the on demand, slightly edited version. This is live. You could go to the text on our website. That's this is streaming over Vimeo right now. So if you're on our website watching this, there'll be some sort of a link
Sure.
in the text below this. But
We just need some
go to
information.
ctmag.com if you want to get a hold of Cutting Tool Engineering. The other thing you can do is get a hold of your new designed website or
Yes.
some sort of new
We have a
enhancement?
brand new website. You can go on there. There's an area right there. You can type in, say, I need help with this thread or something like that. That will be sent out to one of our guys, and then we could go over that online and always in person. We'll get a hold of you one way or the other. If that doesn't work, you can always call Vargus at the office. That's the CSR, and they will get in touch with one of us, and we'll get you an answer to help you with your machining problems, especially in threading.
So, and be sure to type out the full question that or the statement that you need help
Right, and
with
and,
threading, not just
Like
you
Phil
need
said,
help.
we need material, the diameter, the problem you're having,
Okay.
and maybe a couple other things that horizontal machine, vertical machine, some information about the operation, so we can help you. Because the more information we have, the better tool we can get for you.
Okay, and how when did you finish this upgrade to the site?
Oh, the site was finished, I think, February 1st, and there's still a lot more to go. We're going to have online access to 3D modeling for all our tools, which is, I think, 17,000 line items or something. That's being worked on. We're going to be able to go right from the Genius to our website, to our stock inventory, so a place where you can place the order. So if all this is coming, that's going to be down the road, and we'll see how things go. But we have big ideas how to evolve with the 21st century. We need to keep up. The machines are getting better. The tools are getting better. The parts are getting harder to machine, and we need to keep up. So that's what we're doing.
Can you look at the screen there? What's on the screen there? What is the tool in the upper right corner?
The one that's on the right hand side at the top of the block, that's the bell-shaped cutter.
The bell-shaped, yeah.
Yep, it's a tool that's designed to do external threads for fuel rails and different various MPT fittings and things of that nature.
Which is a high production.
It's an extremely fast tool. It circle interpolates around the outside of a boss to put a thread on it. It's crazy fast.
Some of the cycle times are 1 or 2 seconds. So if you have hundreds of thousands of parts, and if you save a half a second per part, my brain can't do that. That's a lot of time.
Okay, but you're saying if you save half a second per part, over what?
For what you're running right now.
And
a lot of
what
times
would
right
that be?
now they would be doing a thread milling on the outside or a threading, like an OD threading. But this comes in, does one circulation, and comes back out, full threads, super fast. But like I said, it's usually ran on big machines that are high production where they're wanting to do a part maybe every 7 seconds. Well, if you have 500,000 parts and you save them a second, you're the biggest hero they've ever walked in the door. So high production shops, this is for that. We've tested at some places where we've saved them 7 or 8 seconds on an application like I'm saying, which is huge money. So that's some of our new innovation tools that we have out there. We need to show and demo, and we'll do that further down the line with this, we'll look at some of our other stuff. Like I said, gear milling, spline milling, things like that.
Well, that's great. So, any other troubleshooting tips that we want to cover?
I would just say, as Joe would say, get online, let us know the issue that you may be fighting, and you will be directly contacted by phone and via email from one of the engineers that cover your area, and we'll be there pretty quick to help you get your problem solved.
So, and like I said, we're going to morph into a little bit higher technical, but still try to have a little fun with this. So, and as long as Dennis is here, we always have fun. So,
I find a way.
and I think we're about to wrap this baby up.
Well, I got something I want to share
That's
because
it. Oh, some more wisdom from Dennis. Okay.
this is Chet. Chet
Oh, yeah,
and
I forgot about
AirPods.
Chet.
So, he says here, it's a little fact, just about to throw in here anywhere I wanted to, and I think it's a good cap for the whole episode. It says every batch of Elijah Craig barrel proof is a little different, just like seed 923 that he originally suggested, and the batch A125 that we're drinking, which is really good. So they're all a little different, kind of like every machining setup that you do. It's a little different from one to the next, even with the same tool.
Absolutely.
Small changes make a big difference. And with this bourbon, and I think we proved that with the technical discussion here tonight, but with this bourbon, thank God for that ice, because it toned it down and helped me make it through this whole episode.
But you're absolutely right. Every application is different. Any little change makes the outcome completely different, just like with the bourbon you're drinking right now.
Yes, and again, thank you to Joe McGee, Phil Gish. That's not one name; it's Phil Gish. Thank you for being here, for making the drive up and over. It's always a pleasure, and it's always fun.
Yes.
To the next one.
Yep.
Cheers.
Cheers. And remember, if you like this, please tune in for the next one.
Oh, yeah, please tune in. And again, always just make suggestions for what you'd like to see us do.
Right.
More of, maybe it's more, the case study approach, or, if there's specific questions, get those questions to us.
We try to give our customers the answers they need.
As we move forward, we're kind of morphing more into those, the technical kind of advice that Phil gives when he goes in person to one of his shops. So I think that's what we'd like to be able to do for the audience here.
Thank you, Dennis, for inviting us back.
Well,
Appreciate it.
it's always a good bourbon. It's always fun to